All right, here we go. Today we're going to start Polygons, chapter 7. We're going to learn about the interior sum of angles inside of a polygon. A polygon is a closed figure formed by 3 or more line segments called sides. Three or more line segments called sides. So like a circle is not a polygon. It doesn't have a line segment as a side. The sum of the measures of the interior angle in a polygon can be determined by the number of triangles that can be drawn within the polygon. It's kind of a little trick. You don't have to do any drawing because I will show you a formula that'll take out the drawing. Okay. Complete the table below and look for a pattern to find the sum of the degrees in any polygon. And then we see this chart. What's the name of the first polygon? A triangle. You see the picture. How many sides does that triangle have? In the picture, right now, how many triangles are drawn? And what do we already know? We learned this last semester. What do we already know about the sum of the interior angles of a triangle? 180 degrees. What's the next polygon drawn? A quadrilateral is the name. How many sides does it have? How many triangles are drawn in that diagram? Okay. We're going to skip the sum of the interior angles for a moment, and we're going to go down to the pentagon. How many sides does the pentagon have? How many triangles are drawn inside of that pentagon? Let's do this all the way down on those columns. A hexagon has 6 sides. How many triangles are drawn? 4, not 5, Mr. Shote. And they moved the eraser button, and not highlighting, Mr. Shote. 4. A heptagon. What do you think a heptagon, how many sides does it have? Let me ask you, looking at this chart right here, the triangle had 3 sides. How many triangles were in it? A quadrilateral had how many sides? How many triangles were in it? A pentagon had how many sides? And how many triangles were in it? What do you think is happening? Every time we go down, we are what? We're adding 1. And then every time we go down on the triangles, what are we doing? Adding 1. Let me state it better because that doesn't actually work out. Every time we add a side to our polygon, we are... How do I go from 3 to 1? This is a better way to do it. Yeah, it's subtracting by how much? How did I go from 4 to 2? How did I go from 5 to 3? How did I go from 6 to 4? So what is 7 minus 2? 5. That's how we're trying to do this. An octagon has how many sides? How many triangles would be in it? A nonagon would have how many sides? How many triangles would be in it? A decagon would have how many sides? How many triangles in it? Okay. So what we notice here is that if I subtract 2, I get my number of triangles. Subtract 2, subtract 2, subtract 2, so forth. So now let's look at the number of triangles times, or the number of triangle compared to the sum of the interior angle. How did I go from 1 to 180? And I'm going to give you a hint. We multiplied. Okay? We multiplied. We multiplied what? 1 times 180. So what do you think we're going to get when we go to a quadrilateral? There we go. And then from a pentagon, and you have those calculators in front of you, 540. So what we're doing is looking at the number of triangles and multiplying it by 180. So let's finish this chart. 4 times 180 is 720. 5 times 180 is going to be 900. 6 times 180 is going to be 1,080. 7 times 180 is going to be 1,260. And then 8 times 180 is going to be 1,440 degrees. And that works great if you're just using that little chart. But what happens if you don't have that chart? Or what happens if you don't have a drawing to see the triangles on the inside? We have a formula that I actually think the formula is easier than trying to remember how the chart worked. The formula, the interior angle sum formula. If n represents the number of sides, so if n represents the number of sides of the polygon, then the sum of the interior angle, which is this column, can be found by using the following formula. S equals n, the number of sides, minus 2 times 180 degrees. N minus 2 times 180 degrees. A 15-gon. So let's look at these examples. Find the sum of the measures of the interior angles in each polygon. The sum of the measures of the interior angles in each polygon. And number 1 gives us a 15-gon. And in a 15-gon, what you need to know is that you can name any polygon. You can name any polygon by the number of sides dash gon. So however many sides it has, dash gon is the name. So how many sides does number 1 have? How many? 15. To find the sum of the interior angle measures, we would say 15 minus 2 times 180. That gives me 13 times 180, and that equals 2,340. They changed some of where the settings are on my iPad. It's throwing me off, so it takes me a little bit to erase. On a 21-gon, we would say S equals 21 minus 2 times 180. That's 19 times 180, which equals 3,420 degrees. Number 3, a 48-gon. S equals 48 minus 2 times 180, That's 46 times 180. And what do we get? 8,280. Now, you probably will get to a place with the formula that you can go, hey, I know I'm going to subtract 2 from the sides and then multiply that by 180, and then I've got my answer. So what's 36 minus 2? 36 minus 2? 34 times 180 now, and I get 6,120. Let's flip it over. We're only going to do the regular polygon section. And what you need to know about a regular polygon is that a regular polygon, all of the angles are congruent to each other. The ones that are interior are congruent to all of each other. The ones that are on the exterior are congruent to the exterior angles, meaning they're the same. So like an irregular polygon, you may have one angle that's 90 degrees and another angle that's 30 degrees and another angle that's 40 degrees, so forth. They're not the same. A regular polygon, they all would be the same. And it says the measure of a single interior angle in a regular polygon can be found by dividing the sum of the interior angle measures, which is what we did on the front side, by the number of sides. Let me give you the formula for that. It is almost the exact same as the front one, which was n, the number of sides, minus 2 times 180. Once you find the sum of the interior angles, you would divide it by, and they throw me off with that eraser, divide it by n, the number of sides. So, let's look at number 5, a regular pentagon. How many sides does a pentagon have? So what we're going to say is 5 minus 2 times 180 divided by the number of sides that object had, which is 5. This becomes 3 times 180 divided by 5, which is going to give us 108. Then a regular 18gon has 18 sides minus 2 times 180. We divide it by the number of sides, which is 18. This becomes 16 times 180 divided by 18. Which is 160 degrees. You got that? Let's look at your assignment today. In a moment, I will tell you exactly which ones you are doing. Let's look at number 20. It says in exercise, let's look at number 6. My apologies. In exercises 3 through 6, find the sum of the measures of the interior angles of the indicated convex polygon. We're not worried about the convex. If you have heads down on your desk, I need you to pick them up. Number 6 is a 20gon. That's where I saw the 20 at. We know that to find the sum of the interior angles, we take S equals the number of sides minus 2 times 180. So for a 20gon, we would say 20 minus 2 times 180. That's 18 times 180, which equals 3,240 degrees. There's my answer. In exercises 7 through 10, the sum of the measure of the interior angles of a polygon are given. Classify the polygon by the number of sides. So they wanted us to tell how many sides does this object have. They give us the total sum of the interior angles. So we have to work backwards. We have to go backwards in the formula. So we have 3,240 is equal to the number of sides minus 2 times 180. That's what we know. We just don't know how many sides it has yet. Well, the first thing I can do is to divide both sides by 180. 3,240 divided by 180 gives me 18. I know that's kind of hard to see there. I'm going to drop it down here. 18 equals n minus 2. So I need to get n by itself. How can I do that? I can do what with it? I can add 2 to both sides. What's 18 plus 2? So 20 equals n. And that looks like a big mess, which is why I often tell you guys to show your work on a separate sheet of paper. The number of sides would be 20. N equals 20. And I'll rewrite this really fast so you see the work. Okay, so there's the work, how we got there. Number 14. Let's look at number 14. The directions state, find the value of x. There's only one x inside of the polygon on number 14. How many sides does this polygon have? The sum of the interior angles of a four-sided object is how much? 360. That means that when I add x plus 92 plus 68 plus 101, that should all equal 360. 360 should equal x plus 92 plus 68 plus 101. That actually equals 261. 360 equals x plus 261. If I subtract 261 from both sides, I'm left with 99 equals x. I had a four-sided shape. I knew that all of the angles inside of that four-sided shape should add up to 360. I was missing one of those angles. I subtracted all of those other angles from 360 and got 99 as my missing angle. Okay. You are doing problems 3 through 17. And I will leave those two examples up on the board so that you can kind of see what I did there.